Hi guys, today we'll make a custom flip simulation and drive a height field with it. Then erode that animated height field using HDA processor in Topnet. So let's get started. So let's start by putting down a geometry node inside a grid. Let's scale it to 1 by 1. Then scatter. We will scatter around 30,000 points. Next a Topnet. Inside we need a flip object, a flip solver, and a multi-solver. And then connect this like this. Also, we need a subsolver. Now in the flip object, first we need to select this close boundaries. Second, we'll change the particle separation to 0.032. This was the final value I came up during my testing. And also let's go to guides particles and display as particles. Next, we need to change the input type to particle field, and to get our incoming geometry points, we type this expression. We have our points incoming. Also, let's disable any visualization. Next, inside the subsolver, first drop a group. Let's call these points effectors. And let's enable these keep by random chance. And let's set the percentage to 0.1. Also, in order to distinguish these points clearly, let's give them a color. Vector points are red. Okay, now let's place down a point relax. And for this, I want to relax the effectors. And influencing points will also be effectors. Max iterations 1. And we do not need to scale by p scale. And relax on 3D space. Oh, so we also need to go to this flip solver and disable reseed particles and also enable particle separation and set the separation scale to 1. And also let's change this to APIC. Now this is the particle separation in action. Now you can, I think, already see these effector particles are just going way out. So let's fix that by changing the point radius scale to 0.1. Let's try disabling relax in 3D space and Let's drop another relax. Here I want to affect everything but the effectors by effectors. Also, I want to relax this in 3D space and point radius scale, I think let's start with 0.1. You can see now that something is happening, but not really looking any good. So let's play with these values and find something that works. Okay, so in this, let's scale by piece scale and see what happens. Yeah, now it's almost there. Try 1 for this. Okay, 0.1. Let's stick with 0.1 for this, and let's go with maybe 1. Yeah, now it's closer to what my intent was originally. So now you can see that these flip particles are trying to stay away from each other and at the same time away from these effector particles. And because these flip points are trying to stay away from each other, and this is a fluid simulation, so these effector points kind of move along with it. Let's toggle real time. So that's the only thing that's giving these effector points any motion. You can obviously think of other ways to give them motion, maybe give them noise velocities and all that. But for now, this looks good. Also for effectors group, let's change the percent to maybe 0.04. So there aren't too many. 0.03, 0.02. Let's also change the seed. This might work. Yes. Okay, let's move ahead with this. Also here in volume motion, let's change this box size to 1.1, 0.1 and 1.1. So this will make sure that our points stay within this box and don't really go out too much. Let's try this again. So now you can see it's kind of doing something. Okay, let's move on. Let's drop a file cache. Let's save to disk in background so we can work while this is working. Now to transfer these points on height fields, let's create a height field first. And by default, you can see the size is 1000 by 1000. Height fields are huge by default. So let's bring it back to 1 to 1, same size as this grid. And also grid spacing is 2, and grid spacing is literally twice the size. So obviously there's nothing showing up. If you set it to 1, still won't show up. If you set it to 0.9, Nothing. 0.5, I think it will start showing up. Yeah. But for this, we need the grid spacing to be 0.005, I think. Let's start there. And grid spacing 2 or 1 is good for when the height field is 1000 by 1000, but when it has been like resized to 1, grid spacing has to get really low. You'll have to kind of figure out how much your computer can handle it. So let's move on. Next, we need a height field warp. And in here, let's plug this and this. And for these points, let's create an attribute f at mask equals 1. Now, because height field is just volume with like x and y scales, and the y-axis of this volume is always only one voxel among in the y-axis. So basically, it's a 2D volume, and because it's a 2D volume, we can do all sorts of volume functions on this, like point clouds and all that. So PC open. Let's plug in our second input. Give it position. Search radius, let's start with 0.032. Or this is the same as our flip simulation, particle separation. Next, a PC filter. We want a float mask. And let's change these to mask. We don't need to do anything with height right now. So yes, now if you play, you can see we have an animated mask. Let's try and fine tune this. This is what we have. So I don't want these things in the middle. So what can I do is blast out the effector group, and that will get rid of these points. Okay, we now have a mask. Keep it to 5, otherwise I'll take a lot of time simulating further down. Okay. Next, I need another height warp, and this would be mask manipulation. Okay. Cool. Let's drop a height field blur. Sorry, wrong one. Mask blur. And again, by default, this is set for like a huge height field, but you can change these. So if we look at this, like this is smoother and it will help us further down here. So inside, what I want to do is, let's change these to mask. and I want to proper trigonometric function. And let's change the frequency to 10 and let's keep offset 0. Okay. So as you can see, this kind of created these outside ridges that you saw in the animation that I put in the starting of the video. So that's how it was done. You can do all sorts of things to mask at like any point. You can add noise or multiply noise or anything like that. So for now, let's move ahead. Maybe height field should be a bit more high res. Yeah. Now it looks far better. So next, let's drop a height field noise. And by default, again, scaled for 1000 by 1000. So let's adjust it. Okay, now you have many options here. You can either just set the element size to 0 and there will be no noise. And if you even like slightly begin to raise this, it will just add noise. At 0, there is no noise. So if you set the height field noise element size to 0 and plug in the mask, it will displace the height field according to the mask, which is kind of what we want. Let's alter our mask blur radius because these are too sharp. Yes, much better. Okay. Now what I want to do is something like this, but let's change this to just play with these settings until you have something you like. For now, we'll go along with this. Actually, it's kind of hideous. Let me change things. That's also, we can drop a distortion node. So height field distort by noise. Looks good. Also, let's animate this distortion. So height field kind of keeps changing. Let's try this here as well. So now we have a height field. Let's change this value so we can have some faster, more like real time. And all right, so this is done. I'll drop another file cache and change the resolution back to 0.002. Let's save to disk in background. And this is not a simulation, so let's uncheck this. So if this is not a simulation, what it does is basically this file cache is has a Topnet context inside of it. So allow editing of contents, and here is a Topnet. And there is a scheduler. And what schedulers do is, like, if we generate this node, it knows that there are 240 frames. It hasn't worked on any of them yet. It's just generating the number of jobs it has to do, and it needs a scheduler to process this top node. So by default, a scheduler has these slots configured to equal to 1/4 of total CPU count. Now let me open the task manager. So I have a 6-core 12-thread processor, and so I can either change this to 1/4 would be by default 3. So if I, let's say, save to disk in background, you can see it's processing 3 frames at a time. Okay. Now if I put this to custom, this equal to CPU count less 1, this would just create 11 jobs at a time. So now it's processing 11. And if this was a simulation, let's cancel the code. Sometimes if it can be a bit jittery. So if we check simulation and save to disk in background, it will only do 1 frame at a time, because a simulation needs data from the previous frame to process the next frame. Okay. So let's cancel this again, and I'll uncheck simulation, and inside I'll set the custom slot count to 2, not 3, so we have some cores left to do other things while this is cooking. This was like cooking really fast right now, but when you do the final simulations and all that with the really higher resolution, then it starts to matter. And I'll set the custom slot count to 2 and go up and start save to disk in background. And another thing you have to keep in mind while using PDG and all is, if I have 32 gigs of RAM, so if there was certain process upstream that consumes about 10 gigabytes of RAM at a time for each frame. So basically, if you set this scheduler to be more than two slot count at a time, let's say if I say here it's 6, let's imagine it's 6, and it's processing 6 jobs at a time. So what will happen is it will try and allocate 10 GB RAM for each work item, and that would require 60 plus gigabytes of RAM, which we don't have, so it can lead to issues. So you always kind of have to be mindful of how much RAM you have. while using this thing. So, and it's this file cache saved to disk in background is also good for like when you have a, let's say, a sphere and you plug a mountain node, and let's say you animate this mountain. Okay. Now I want to remesh. Let's say to something really high, 0.02. So what this can be useful, for example, if this isn't consuming a whole lot of RAM, you can just uh, tell this to, like, in here, set the custom core count to this equal to CPU count less one, and it will, like, if you have a 32 core processor, it will just do 31 frames at a time. And remesh is a single core process, as far as I know. It isn't multi-threaded. So what the advantage of doing a file cache like this with the top context is, if you have an animation and you're trying to remesh that animation, it will go a whole lot faster if you have enough RAM. A whole lot faster, like almost 10-11 times faster, because then it's like processing 10 or however many frames at a single time, because this is a single thread and it will just start a multiple of these frames. So all of your threads are like processing different frames. So enough about that. Let's get back to this. So now you can see we have processed 48 frames. Okay. What can we do now? Yes, we need to erode this. So let's drop a erode. And erode is by default again configured to work on 1,000 by 1,000 height field. And these settings won't help a lot if you just have a 1 by 1 height field. So let's try this. So if I play now, you can see the erosion just goes crazy. Like, this is useless. So for that, let's drop a height transform and let's scale to 1,000. Then let's take another one and copy parameter. And for this one, set this to 1 over paste relative reference. So if we try and erode this now the erosion works like it's supposed to. What is happening here? A viewport is acting up, so I don't know. So yes, also what this erode does is it takes the first input, the first frame that's coming in, and erodes that. It doesn't work on like animated height fields, but that we can do with PDG. If we want to erode animated height fields, it can be done with Topnet or PDG. Like, I don't know what to call it at this point. It has two names for some reason. Okay, if I click and drag, it just disappears for some reason. So yes, you can see it's eroding. All right, let me get here. Place the viewport camera in. Okay. Now you can see the erosion is happening. Cool. But it won't work for animated height field. So what can we do about that? Okay. Let's drop a null. Next, we need a topnet. And inside, again, we have this scheduler. We will set this to custom slot count 2. Or let's just set it to 1. Or another way of setting this to 1 is like go to job arms and select single. So if you are processing something that is multi-threaded like a smoke simulation or height fields, erosion is multi-threaded process. So if you do one at a time, the advantage would be like it's already using all the processor cores, so you don't need to like solve multiple items at once. So the single works for that. It will, because if you solve 2 frames at a time and each of them only has 6 processor cores or 4 or 3, so like that would be a bit slower. So for that, let's drop a file range. So what file range does is it reads file range, like it's that simple. Next, let's copy Control C this and get here Control V. Okay, and inside here there are 3 things, basic things that you can do to any topnet node. You can either generate node. It will only look up and see how many files are there. So there are 120 frames at the moment we did this generate node. Now we have 122. So it hasn't cooked any of them yet. Cook is like processed any of them yet, or you can cancel this. And if you have, let's say, cooked, Shift V is the shortcut for this cook node, dirty and cook node. And if you if you want to change this again, like if you don't, if you have made any changes upstream or like what I'm trying to say, so you just go ahead and dirty node. So this will just collapse it back, and then you can dirty and cook this one. So we have it again. Next, what I'm going to do is drop a file range, not file range, filter by range. What this does is, this is great for testing. Like I have 132 incoming frames. I don't want to process all of them while I'm still testing the whole thing. So let's say I want to process 5. Let's scope this. So it will just take this range 0 to 5 and load it here. So only these 5 frames will be processed further. And at this point inside of Topnet, I don't think these work items are considered as frames anymore, because this Topnet kind of works differently. And if you want to know more about this, the perfect place to like read a bit more would be CGV. Like inside option PDG. So I really recommend reading this up. It will like really help you out. I'm still quite new to this, so that's why I'm fumbling so much with my words. Yeah, so read it out. It will be of great help. So let's go ahead. Next, now we have our files figured out and loaded in here. Let me cook this again. We have 158 frames by now. And next we need to process these frames one at a time and erode them. And for that we need a HDA processor. What this does is you can tell it load up this HDA and it will just work this HDA on every single work item. So we don't have our HDA, so let's make our HDA. Another geo node here. Let's call it loader. And inside drop a file. Then a transform. Not transfer form, heightfield transform. The same thing we did there. Multiply by 1000. Copy parameter. 1 over paste relative references. And then erode node. Now this will display errors at this time because this file is nothing. But we'll deal with this in a bit. This time shift will replace this functionality here, because I think it would be better if we just keep it separate. Okay, now we have this setup. So let's go to edit parameter interface, Control A to select all, invisible, apply accept. Now again, and now we can promote these parameters. Geometry file, we will set this later on, and this timeshift frame number. You can also promote all of these parameters, but for the sake of this video, let's just move on with this. Okay, everything is done. Apply, accept. Now I want to right click on this, go to digital asset, create new. We don't need any of these. And library path, I want to use hip file directory because I only want to use this asset HDA only in this project. So this, let's create. Now destroy all spare parameters. So let's accept. Now we can remove this. And we should have it right here. Yes, eroder. This is our HDA now. Okay. And if you want to do any changes, just go allow editing of contents, make the changes, and again just repeat this process, save as, or just just a second. Digital asset, save as, and overwrite the pre-existing one. It'll work fine. We don't need this. Let's go back to our Topnet and locate our HDF file. Here it is. Cool. Now I also want to write outputs. I don't need any SOP path. We are not referencing any SOP from here, so leave it blank. So for output file name, I want to go $hip geo and let's say HF. And now if I put under like a dollar F here, it won't work. It will like do weird things. Not really work. Like sometimes it just overwrites a single frame. Like so for this, we need to look at these individual job items. Double click on anyone, and you can see it has a number of attributes here, like index, priority, frame number, and all these. But because our HDA will be processing each frame for a number of frames, the overall frame count will get weird. So instead of using the frame number, we will use index. So if you see, the first job item has an index of 0, the second one is 1, and the third one is 2, and so on. So how I want to save this is backtick at PDG underscore index. That's how you reference those attributes. And these are again also available in the CG wiki page I just showed. I just opened up a few moments ago. So, and let's do a +1 and again backtick. Why I did PDG index +1 is because the index starts from 0, but our frame number starts from 1. So it will be easier when we load back the files here. It will just be easy. You can either, if you don't want to do like +1 here, you while loading it, you will just have to do a -1 there, $f underscore -1. So it loads up the correct file for the correct frame number. Okay, another thing let's update HDA parameters. And when we go here, geometry file is default .bgo. We don't want that. We want these incoming files. And if you again open these, it has these string attributes. These pink attributes are string attributes. So we have a directory and a file name. So the path for each of these job items is this directory / file name, right? So what we will do here is uh, we'll do add directory, add file name. I don't think it's file name. Hold on. So directory and file, I think it is. It should be saving now. We'll soon be able to see if I input the correct attribute or not. Let's drop another file. And let's point this to geo HFERD, and let's wait so one of those work. We are only loading this for frame 1. Okay, that's better because we are testing cell. Okay, it's not writing out anything and it's showing that it's already done, but there are no files, so we did something wrong. What did I do wrong? Let's see where it's saving. Hip geo hf underscore erd. Okay, we didn't put any extensions. Let's see what happens. Yeah, now it's saving them. Now I can just go here and type $f dot bgo dot hc and it should load them. Like you can see, it's loading 2 frames here, but we didn't really erode them. We only did it for 1 frame and it doesn't really do anything in 1 frame. But now we know this whole network is working. So let's get back here, and in parameters, let's say for 10 frames, let's process it for 10 frames, 10 here. So again, let it process and the files will load up. Also, you have these buttons here with valuable information. Like this is showing how many jobs it has done. So you can see it says 250, 252, 240 of these, 10 of these, and 2 of these. That's how it gets this number. One is running, this light green one. 7 are waiting. These now 6 waiting. These are the failed ones, I think, and these have some error. These are, I think, errors. And you can just cancel cook the output nodes work items, and cook the selected nodes work items. So if I just select this and do this, it will only cook this and not these further one. And if I have this selected and I click on this, it'll just cook all of them. So yes, this is quite helpful. Okay, it's almost done. Let's see. Yes, now you can see that there is some erosion here. Okay. So that's how you erode animated height fields in Houdini. It's a bit of a workaround, but yeah, it works. And because this is Houdini and Houdini can do weird things, we don't have to limit ourselves to these. We can also, like, say, make a 2D smoke simulation and drive a height field with that. So for that, I guess let's drop a grid. I'll make it really fast. 1 to 1. Then what I want to do, scatter. Let's make it a circle instead of a grid. And let's put it in the ZX plane so it's flat on the surface. And yeah, now it's a better circle. Next, a pyro source. And we want to initialize source smoke. Next, what we need is a attribute rasterize. Volume rasterize attributes. These node names just flow off the tongue so easily. Okay, so here we need attributes density and temperature, and I only want to look at density. And this only changes what you can see here, like it doesn't change any data. And if you want to just see that temperature, you just change it, and now you only see the temperature volume. Topnet. Let's keep the size 1. Let's keep it 5 by 5. And let's change the size of the circle to 0.2. Now if I play this, nothing is happening. Why not? Because I haven't sourced any volumes yet. Okay, let's put this here. And now we have all this coming in and it should work. It works. Let's also give it some point velocity. For that, let's create a velocity here, and default value will be 0. Let's drop a point velocity and plug it right here. I want to add curl noise and let's keep it animated. Also, what I want to do is copy this parameter and yeah, here. Let's play paste relative reference. Now we have the same size. Also, this is like really thick for a 2D smoke, and the points are actually on a 2D plane as well. So let's drop the particle scale to 0.1. And forgot to do this. Now we have a 2-dimensional smoke simulation. And if I borrow some nodes from here, I need this, and I need this, and this. Okay, now my height field is only 1 unit squared, and this is like 5 by 5. So let's transform. Does it work? I don't know. I type like an idiot. So, okay. If I just do 1/5, will this work? Yeah, works. Good enough. Drop a volume slice here. And we want this on ZX plane. Okay, now there is no control here for this grid. So if you want to if you need a higher res grid, there are two ways. Either you upscale this resolution something higher, or what you can do is just drop a grid, and again we want this to be 1 by 1, and I want 100 rows and 100 columns. It's already, so let's 500 and 500, much denser than this one. Then attribute not an attribute transfer, attribute from volume. I think it's just taking in the density and outputting the color attribute. let's call it mask. So I can just plug in 10 here and it should work. Yeah, now you can see it. We have this mask. And if I connect this here, okay, I didn't plug the mask. Again, like, there's no vaccine for stupid, so like, let's continue. Drop a mask clear so we can look at it properly. Okay. And then we can just send it. Sorry, I kicked the microphone. So we can just send it to our Topnet and have these eroded as well. So, yeah. So these are like some of the interesting ways that I find interesting, at least, to manipulate height fields. And you can like always increase the complexity in these situations, so you can create amazing stuff. These are just like basics for me to be able to show you the base concept. So let's check out our eroded. Like you can see the erosion looks really good without erosion and with erosion. Like I really like this effect, and this is probably the first time this is definitely the first time I use the HDA processor, and it, it can be a bit of a learning curve, but as long as you remember a few key points, like don't treat these work items as frames. These are not frames. Sometimes $F or treating them as frames work sometimes in some cases, but not all the time. So be mindful of that, and always look at this directory and file name and all that, and just keep your files in different folders, and I think you should be good. It's not that difficult. And sometimes, like working in Houdini, you kind of almost always have to consult the task manager and see what sort of torture your computer is going through. So, yeah, that's all. Let me see if I'm forgetting anything that I might have missed. I think we are good. So, if you have any questions, leave them in the comments or DM me on Instagram. I don't really use Twitter that much, so like, yeah. If you create anything using all this, feel free to tag me. I'd like to see what you guys come up with. And yeah, that's all.